Webinar is hosted by the Reforest Canada Collective, or RCC. And if you haven't heard about us yet, we are a division of Forest Canada that launched in December of 2024. The RCC's community of practice and platform where Canada's tree planting network can connect and collaborate, share knowledge, and we invite you to visit our website to learn more and reach out to us to discuss any ideas you might have about how the RCC can help your organization. Jumping right in today, we all know that climate change has and will continue to change and affect our Canadian forests. This leads to the knowledge on tree genetics and seed provenance becoming very important in the forest recovery process. So whether it's renewing managed forests after timber harvest or restoration following disturbances like wildfire, beetlekill, it's important for us to consider the future conditions of climate when choosing the right species for the site. We have a great set of speakers here today to share their work and perspectives on this emerging topic. But before we get to the speakers, I do want to thank the Toronto Stock Exchange and their partners for including us in this week's set of Canada Climate Week exchange events. These events are dedicated to collaborating on solutions and opportunities to address Canada's unique climate-related challenges. We'll hear from 5 total speakers today, tuning in virtually from all over Northern Turtle Island, and we'll go through the Q&A at the very end. So save your questions till the end. You're welcome to write them in the chat, but please use the chat box that's called Q&A, and be sure to include the speaker name as well so that we can remember who you'd like to be addressing the question that you have. We welcome participation as well in the chat, so feel free to introduce yourself now if you like. Let us know where you're calling in from. Include the traditional territory if you like. I'm tuning in today from the traditional territory of the Haudenosaunee, also known as Kingston, Ontario, where I reside. So I'd like to first introduce Dan McKenney, and we're really happy to have Dan here today, who's joining us to help us open the session. Dan is a research scientist and team leader at the Great Lakes Forestry Centre located in Ontario, Canada, and he's involved in economic analysis and the development of geospatial data and tools. The goal of his team's work is to support the sustainable management of Canadian forests by focusing on spatial analysis needs and opportunities. He also works on examining the role of climate and natural systems and conducts climate change impact and adaptation analyses. So thanks, Dan, and kick us off. So
Okay.
I'm going to stop
Thanks very much,
sharing.
Amber. And thanks everybody for basically joining in today. Let me see if I can get this right
Yeah. So just close down the Zoom window.
from the beginning.
There
Are
you go.
you
Yeah,
seeing
yeah,
that?
we're in
Okay.
action. Yeah.
Okay. All right. So I basically was asked to give a bit of an introductory talk on the need for tree species climate adaptation, why and what. So I just want to acknowledge John Pedler, my collaborator on this. I've worked together for a number of years on these and other topics. So my talk today, just going to give a little bit of climate change context, some of which I think probably are quite familiar with many of you, maybe not, maybe a few new things to say about it, some implications for forest, and I also wanted to say some things about implications for decision making. And the 2 pictures there on the screen show, I think, familiar faces and also basically a little bit of a play here on the part of the problem that we humans are a little bit like the frog in the boiling pot of water. Except in this case, we actually also have our hands on the burner down below. So just to give a little bit of an overview, this is some science that's been based on assessments of carbon dioxide that's been in the atmosphere over approximately the last 800,000 years. And you can see the fact that it basically, until the Industrial Revolution, was about 300, 270 parts per million. And over much of recent times since the Industrial Revolution, it's gone up. That's not changing. It's still increasing. Last year, it was at about 422 parts per million. It's very strongly correlated with temperature increases. The science behind that is pretty clear and unequivocal. Basically, scientists, one part of the climate change community, tries to figure out how climate might proceed over the course of time with increases in greenhouse gas emissions. Uncertainty is a key issue in relation to dealing with climate change, including the topic of the day here. How do we have more resilient forests? This particular figure shows some of the main sources of uncertainty. Scenario uncertainty, which is basically the emission paths that civil society might follow. So there are a number of them there. These are probably the largest source of uncertainty associated with how climate might evolve. Model uncertainty. So there's probably, I don't know, I think 15 to 25, 30 different groups across the planet that are involved in this kind of modeling. It takes a lot of computer power to do this kind of work. So every one of them has a slightly different approach based on the basic underlying physics, but there are obviously some differences. So you see model uncertainty in this figure as well, which is sort of the gray color underneath the averages of the different emission paths. So the internal, there's something called internal variability, which is about the volcanic cycles, El Nino, La Nina, some of those types of things that are basically not particularly represented in the models, but they are also part of it. But the overarching cause of the differences between the outcomes that you see, which is temperature changes on the left side of the axis there, um, have to do with the different levels of greenhouse gas emissions in the atmospheres. There's a wide range of possible outcomes. Um, they used to be called RCPs. They're now called SSPs, which is a shared socioeconomic pathway. So there's our assumptions about how civil society might deal with a change with the problem. The big thing here, I think, the takeaway is that in the not too distant future, average conditions are going to be greater than the extremes that we have faced. We are now locked into fairly significant change at the big scale. We don't know exactly what it's going to be in a particular location in whatever, May 24th, 2047, but that's not the point, and that's not the problem that we as the forestry community have to deal with. It's trying to figure out what all this means at large spatial scales. So, and I just threw this little picture of a book cover here, one that I'm reading. I think it's a good book. We're not trying to be super forecasters in this, but we are trying to figure out the big picture, like I said. And this particular book has been called the best book to come on stream about human thinking and the art and challenge of predictions since Daniel Kahneman's Thinking Fast and Slow. Daniel Kahneman was a basically a psychologist who won a Nobel Prize in economics. Um, So what does this mean for, let's say, a place like Sault Ste. Marie, where I'm residing? And what does it look like for the big picture of Canada? So in Canada, patterns are similar to those that you might see in a global map, but with greater heating changes, the further north you go, that's what's expected, the way that the Earth's climate works. Um, so under a relatively low emission scenario, the 2.6, the changes are basically 1 to 3 degrees in terms of mean annual temperature, and 5 to 9 degrees under the higher emissions RCP 8.5. So in the Sault Ste. Marie region, that 8.5 scenario means an increase, basically a doubling of the mean annual temperature uh, by the latter part of this century. That's a big deal. That's a big deal for the forests that we live in. What does that mean as far as a place like Sault Ste. Marie? So this is another sort of bit more context or another look at the interpretation of the big picture. Here we used a tool of ours that we developed a number of years ago called Seedware. Seedware is just meant to be a play on the word software. It's actually just simply a climate similarity model that helps address questions of seed procurement and seed deployment. You can pick variables, and it will map out the similarity of climate. So that sort of darker orangish reddish color shows you where the climate is similar to the selected choice. So it's handy for questions of seed deployment and seed procurement. So it certainly suggests that with the picture on the right side, that the Sioux's climate is going to be closer to climates hundreds of kilometers further south. It's not a blanket similarity, and it's driven by the climate variables that we chose in this particular example. But the point is that local climate won't be local anymore, and it's already increasingly the case. So there's another factor that we have to think about with respect to forests, and that's that there are extreme weather events. This particular figure shows that the expected return time of extreme temperature events under the 2.6, the lower emission scenario, is for something that currently happens maybe once every 50 years, it could be expected to happen once every 10 years or so by the year 2050. And under the higher emission scenario of 8.5, the RCP 8.5, this once every 50-year scenario could be expected to return once every 5 years. and even more as the century progresses. What about precipitation? In Canada, annual precipitation is projected to increase across the country, um, typically between 0 and 20%. Doesn't sound much until you start looking at extreme events, but overall, it's expected to increase by about 10% on average. That's because there's more energy in the atmosphere. It's just going to be a warmer and wetter world in general. But annual variation can be expected to be very high, which suggests that there are going to be years that are much wetter and some others that are going to be much drier than the average. So what about extreme events with respect to precipitation? This particular figure, and these figures come from a report by Environment Canada a number of years ago. This suggests that under the 2.6, an event that currently happens once every 50 years could be expected to happen at once every 25 years by the year 2050. And under the more extreme scenario, an event that currently happens every 50 years might happen once every 20 years or even 10 years by the end of the century. So I just want to note that we're probably tracking along the lines of the 4.5 or the middle of the run, not the low end scenario. So it's perhaps between the 2.6 and the 8.5. So this particular image is just a picture of the drought intensity. I think probably everybody knows who sees the news about fires in the last few years that Canada's been experiencing dryness. This year being no exception to that. This was the drought map for Canada, September 30th this year. Basically, it shows that much of Canada is under either sort of just drought, abnormally dry, to basically extreme drought. So, and it covers much of the country, which is seemingly something new for the people in the fire business. It's often just one part of the country that has had experiencing dry. So, and in fact, this past year, I think they just changed the numbers. We had a year of about 8 million hectares burned this summer, which is actually the second most on record. And in 2023, it was about 17 million hectares burned, which is by far and away the highest on record, the most on record. And it was, again, as I said, coast to coast, which is quite unusual. So um, the climate moisture index is something that is basically a reflection of the difference between precipitation and potential evaporation, something that forests, distribution of plants, animals, and that respond to this sort of thing. And it shows that you can look in the prairie area and you see the darker reddish color and the transition zone between the prairies and the boreal forest regions. That's basically that sort of zero value is one that is the transition of having forests or not having forests. And as the century progresses, we can see that sort of average condition gets larger and larger, which suggests that forests may be threatened with respect to their very existence. So in some parts of the country. So what does all this climate change mean for forests? Well, clearly one of the potential outcomes is direct mortality as a result of extreme weather conditions like droughts and late spring freezes, floods, windstorms. These impacts are going to affect both sort of local scales and even larger scales, but they are very difficult to predict with spatial precision. Precision. What about fires? This was it's obviously a thing that we're seeing now more and more, it seems like. It's very salient to us. This was some work that I was involved with, but John and I and others were involved with a few years ago. We correlated that climate dryness, not the actual fire weather index that's used in day-to-day management of fire issues, but that climate dryness, which is a big picture sort of correlate. We correlated that to area burned and then the cost of suppressions. We got very high statistical correlations, especially for the Western provinces. And then we simulated that going forward under the various emission pathways. And what these figures show, you can see the dotted line there in the cross for each province, is that basically 3 in 30-year events will become more and more like 25 or even higher in 30-year events by the late century as far as the area burned. And in our modeling, we did not allow for forests to reburn for at least 30 years after the fires. So we're not saying that this is actually going to be what happened, but we actually did this work before the record fire area fires of the previous few years happened. But I think the point is that with the kind of climate that could happen, these kinds of fire regimes are quite possible and are going to challenge the forest community in many ways, from human health and safety to forest regeneration processes. Are areas that burn and then regenerate and get to a point where they become fecund with their ability to reproduce, is that going to be, are those trees going to be given enough time? So what about things like forest pests? Again, the question is, how is it going to change distributions, abundance, and productivity of not just the forest, but the pests themselves, because they affect the forest? Mountain pine beetle is something that's quite well known across the country. It was native to British Columbia. It's been expanding for a number of years. It killed more than, I think, 10 million hectares of lodgepole pine in Western Canada, but it's jumped the Rockies and now in the prairies. There's concern about it spreading further east. Our climate habitat maps of this species suggest that the most suitable habitats are going to be further north, but that it certainly could become something that could be more of an issue in eastern Canada if the host predator interactions allow it to do so. Well, that was basically a native pest, but what about non-native pests? So here's another example. This is a southern pine beetle, and this is basically another climate relationship between the distribution of that organism now and how that might play out going forward. And this shows that significant portions of eastern Canada will likely have climate suitable for this species within the next 30 years. It poses a significant threat to timber species in eastern Canada, including red, white, and jack pine. So what about trees? So we've done that sort of work as well for tree species. We've got a website called planthardiness.gc.ca that has individual species models for literally thousands of plant species. And what this shows is that there is going to be a northward shift in the climate habitat of many species. This was done for some 70 odd main commercial tree species. Trees won't be able to keep up with in terms of natural tree migration with the speed of this type of climate change. So the idea of assisted migration is now increasingly in the Canadian forest policy agenda. There are different kinds of assisted migration. It is something that it is somewhat controversial, probably more in the context of animal related assisted migration more than trees. But for trees, there are definitely questions to do with the ethics and efficacy of moving trees outside of their current ranges. But that's not what assisted migration completely means. There's different kinds. We're talking about things like assisted gene flow, where you just move some of the genes further north within a range. We might also be talking about assisted range expansion. And then there's something like long range assisted migration for things that are probably more of conservation issues. So there's a number of aspects to do with assisted migration that we have to think about. In Canada, we've got well, in the US and Canada, some 1.5 million hectares are reforested annually in Canada and the US. Some 5 million hectares are harvested or burned annually that are allowed to regenerate naturally. So that's on average. So should we be thinking about assisted migration to all these areas? What's going to increase the probability of us having more and more resilient forests? What are the opportunities, risks, costs, and benefits? The questions to do with the economics and risks is some stuff that John and I are particularly interested in and actively pursuing some ideas with people like Kerry, who are our next speaker. So I think the whole idea of assessing assisted migration, not just in terms of local situations, but also in terms of the big picture, is something that we need to be thinking about. But it's a tricky subject, in part because humans themselves are tricky. I just wanted to make like a couple of short comments before finishing with my last slide here about human decision making, Behavioral economics, something that I've got a strong interest in, for those of you who know me. Um, they're Behavioral economics and psychology are increasingly studied subjects, particularly on how we make decisions on an individual basis, not necessarily in organizations, although that's part of the challenge that we face. We make decisions based on emotions, not necessarily calculated assessments of cost and benefits. There are a number of heuristics that are identified in the bottom left of this slide. Things like confirmation bias. So we often look for things that just confirm our predilection of a decision. Optimism bias, framing effects, how we talk about a problem can influence how people think about it. Um, and I think that assisted migration is something that we need to be thinking about in terms of what cognitive biases we bring to the table. Even the title of that bottom paper on the right-hand side of the slide is something that tells us about a bias that we might have. Rapidly declining remarkability of temperature anomalies may obscure public perception of climate change. We are like the frog in the bucket. So just to conclude, Canada is projected to experience increased temperature, higher precipitation, more extreme weather, and novel combinations of these things are inevitable over the coming century. Um, we could be getting in places an overall drier future, but certainly interspersed with wet at times. So we are locked into some of this change, and current emissions suggest almost a 3-degree overall global warming. That was something that was stated in the recent COP that just finished or is finishing. Um, Lots of impacts for forests. I think we can safely say that local climate is not local anymore, and that affects the thinking about the genetics of the challenge. It's not easy. It challenges our thinking. I think personally, I think we need to recognize how we think and bring that into our debate and our discussions about things like assisted migration. I personally think assisted migration can help, and the speakers that are ahead of us right now can help bring some perspective to this particular challenge. Thanks. I'll leave it with that, Amber.
All right. Thanks, Dan. So
Okay.
I'm just going to quickly share my screen again. That was great. Okay, so now we have Kerry. Let's see here. Okay, so we have Kerry McLaven as our next speaker. Kerry's the CEO of the Forest Gene Conservation Association and the president of the Canadian Forest Genetics Association. At the FGCA, Kerry works with a team of 10, and in the latter, she works alongside an incredible gene conservation and tree breeding network across Canada. Kerry's worked in the past for not-for-profit for over 13 years and has worked for FP Innovations, Ontario Parks, and Outland Reforestation during her degrees. Thanks, Kerry, for being here, and take it away.
Excellent. Thanks, Amber. I share on here. Good. Okay. Great. Thank you, Amber and Dan. Always kind of ahead of us on that research is exactly the way that things go naturally with us, Dan. So thanks for your time. I currently reside in territories of the Anishinaabe, Haudenosaunee, Wendake, and Mississaugas. And I work and our team works across all of Ontario and helps to teach folks all across Northern Turtle Island, as Amber had said. And I'm ready to just scratch the surface on this topic with folks here today. And I recognize a lot of names in the participants list there. So hi to those I know. Hello as well to those I don't. Um, I'm just talking to you today about our experience, lessons learned in procuring seed and stock and material and moving it. And we've been doing this work for over 15 years now at the FGCA and many of my predecessors long before that. So happy to share what we've learned and take us through this portion of the event. So as Amber mentioned, I am the CEO of the Forest Gene Conservation Association. We're a not-for-profit organization based in Ontario, focusing primarily on genetic diversity, gene conservation, and tree breeding work in the province of Ontario. But we know that a lot of our work touches people all across Canada. And like Amber mentioned, we collaborate with individuals that are doing similar work in other parts of Canada. And in, all this type of work varies provincially, which I think there are a couple of other speakers from other regions. So really great to be a part of this and really happy to learn from folks on the call today about their experience as well. As a nonprofit organization ourselves, we are often thinking about the very long term, but working to translate this knowledge to people who are working and doing the important restoration work on the ground now. So we know the science is there, the climate has changed and is changing. Now, what can I do as a practitioner to implement actions? What's the first steps? And oftentimes this is where we come in to support organizations. As in order to do this important work and this vision of genetic diverse habitats and landscapes and resilience, we focus on four main program areas. So tree species at risk, Ontario has some of the largest list of species at risk in Canada. And so we deliver tree related recovery programs for species like butternut, black ash, and other species of concern. Seed expertise, we have a training program, which I'll talk a little bit about today, but really is trying to increase the volume of the high quality seed that is used for these types of initiatives and larger ones, and also source identification, which is the important topic today. Climate change adaptation, we are not researchers, but we take a lot of the research that folks like Dan and John and Trevor and many others are working on and put it into practice where we can. So you're here because you're kind of interested in moving material or moving seed, or you have done it and you want to learn more. So ultimately, first step is picking the right species for the right site. I am a huge proponent of moving material, again, supporting Dan and John and others' work. But the important thing too is if you don't pick the right species, given the soil conditions, you're really off to not a good start. So that is, major consideration. The other thing to think about is how readily available is this species or is this provenance or the origin? There are projections looking at how far you want to go, but are there natural stands of those species in good standing? In your planning and your work to do this, whether it's research or operational, have you considered seed needs versus stock needs? Because not every seed produces a tree. Some cases, you're talking 4 seeds to 1 tree, 2 seeds to 1 tree. It varies by species. It also varies by grower in the way in which they grow. So another consideration in your planning. There is seed collection timelines and costs. Again, it's not like you're going to Home Hardware to pick out a bag of seeds. This may not be sitting on a shelf. It may not be a species that can be stored. Stock types and planting windows. Organizations like the Canadian Tree Nurseries Association and others, have a good network of nursery growers that grow different types of stock. And you may be waiting a year until that tree is actually available for planting. And so those need to be considerations in your planning. And as I mentioned, knowing if it's an operational planting, so you're just looking to move a little bit of material to create a more diverse forest restoration project, or is it research planning where you need to know exactly the tree that seed was collected from? These are different scenarios and can take different planning windows. So whether you want to move material or to continue to use local, because that is still happening, number one is sourcing from healthy populations to avoid poor genetic quality. We really want to do make a better forest than the way we've left it. So making sure we collect from high quality stands. Sourcing from a variety of sites, because oftentimes if you're sourcing from one site, those trees are related to each other because the seed fell from 2 parents, and then that continues to go naturally that way. So we want to pick from a number of different sites from a number of areas to increase that genetic diversity. And then ultimately is documenting where the seed is coming from. So we say we want to go and source all the way down here to get that material. But if you don't know where it's from, you really can't make effective decisions on where to move it. So that documentation point is really important. Other planning considerations, I mentioned a couple of them, but the status of the seed banks may not be ready to respond to new assisted migration demands. So it's really great when people have this, I'm ready to go, I'm ready to move trees, but you have to know whether it is a seed that can be stored and is stored in a seed bank, like the one you see in the top right there. That's a deep freezer, -20, with bins full of, pine spruces and others. These are seeds that can be stored. Whereas if you're looking to move hardwoods like oak and maple or whatever else, these are not species that can be stored in seed banks for long term and have to be collected fresh. So there's that fact from the seed side of things, but also, do the nurseries have trees ready for you of those various provenances that you can be sourcing from? So this is an important planning consideration. Seed is also a very undervalued element of the tree itself. You may be paying $1 a tree. Maybe that's crazy, 60 cents a tree, whatever it is, forest restoration or reforestation. Seed is in that cost. And, everyone's trying to get the prices down. So really, if you're looking to procure seed, over the border or from a southern area, you have to factor in the cost it takes to obtain that seed, and you may actually have to consider cost to shipping and moving that material and transporting it and that sort of thing. If there are organizations that aren't mandated to collect seed by a particular source, or if the minimum source documentation is like a seed zone or an eco district, that may be a very large scale that people are looking at documenting information, whereas you may want it from the municipal level or the county level. And so you're going to have to think about, how do I get that information, or who has material that has that level of detail in the sourcing. And of course, international shipping. Down the bottom right there, you see this big reefer truck. Well, oftentimes, that was white oak that we were transporting over the border. We knew it was going to take some time. We needed to arrange a reefer truck to get that material over the border. And there's also phytosanitary and everything else we need to consider. So important elements to consider in the planning process when moving trees. So I'm not here to discourage you by any means, quite the opposite, actually, but I certainly don't want anybody walking into this with eyes wide shut. This is just our experiences, and we have lost sleep over a reefer truck traveling over the border, and so I definitely want folks to learn from this experience. So, like I said, pick the right species for the right site. How readily available is the species, and have a plan that includes seed needs, seed collection timelines, and stock types. So with seed sourcing, you can control the source as well as monitor the performance. So Dan was saying, we're moving material that we want to be adapted to a future condition, but it also needs to be able to handle today's conditions. And so in the short term, when you move material from a known source, you can monitor survival. How does it survive in comparison to its local neighbor? And in the long term, you can monitor things like seed production, and is anything different from that perspective. You can also monitor for frost cracking. That's what we've noticed in some of our trials that we've done. Some of the southern, like Tennessee, oak species have significant frost cracking, but are still surviving. Well, that has implications for wood quality. So someone like, that is working on this from an economic perspective, wood quality, that might be something that might be a decision-making factor. Other work that we don't do ourselves, but again, working with Canadian Forest Service, is seeing how growth rings are affected by the various sources and provenances on the same site. So there's lots of performance monitoring that can be done. You don't have to be a researcher to do it. It could be observational performance monitoring, but certainly this is something that people are studying at a larger scale. The other thing that we're looking at when we create a site for assisted migration, we're often looking at is, could this be a future seed source for the region in the long term? So there's lots of opportunities with this. With the wild seed collection, one thing I'm definitely going to talk about, or just sort of mention today, is the seed manual that we've produced. There's a lot of guidelines on how to capture that genetic diversity. And there is a certified seed collector program and a certification program that we offer to help track that source and make sure that you are having good documentation. The person is trained and knowledgeable about the ethics of seed collection, both respecting the land as well as, being true to the documentation. what you write is actually what the situation is you're collecting in. So if you yourself are not a collector, you are going to be relying on collectors to obtain the material that you're looking for when you're moving it. So at minimum, what I would recommend is that you encourage forecasting to predict your own costing as well as planning for establishment. So, you might, if you don't ask for this, you might know in August that there's a collectible crop and they can get this much, and then you have to arrange everything to get that material moved or source that material and get your site ready. Whereas if you encourage forecasting, you can make some better plans and adjustments to that and contact a nursery that can support you. In making sure the collector is assessing quality, something like cut tests or float tests, things that very basic things that anybody can do to assess the quality, the physiological quality of the seed. And there's many, many other elements, again, just scratching the surface. If you're looking at other seed sources, there are multiple others outside of wild collection. There are seed orchards, seed production areas, and seed collection areas. There are some formal definitions to these different types of genetic installations. And so when in doubt, I would say ask an expert on tree improvement or forest genetic resource management. But in some cases, these can be sources of seed if used appropriately. So these are usually, controlled sites or sites where there were trees that had special qualities or traits or characteristics that people were selecting for. So there is a possibility to source for some of these, but for sure you need to know their origin and their intended uses. So I have sound in that one. So I'm not sure if you can hear that. It doesn't need to have sound. Just some key takeaways is it's really prioritizing genetic diversity over all else. I mean, Dan mentioned some of the conditions that we're going to be facing, but trees are genetically unique. They're adapted to many, many different conditions. And so really the best thing we can do, pick the right species for the right site because we know soils are relatively unchanging. They will probably change, but not as quickly as the climate. So we have to make sure that that's happening and making sure we're collecting seed or stock that has clear source documentation. Careful planning, knowing how long you have to plan to make sure you're having a successful project is important. Considering seed sourcing timelines and in your whole project establishment and costs. And certainly learn from previous experiences. Don't reinvent the wheel. There are organizations across Canada that have been moving seed and transferring material for many years. Share successes, share your failures so we can all learn from this process. And maybe this is a platform we can share it on going forward. And of course, I'm going to promote our seed manual. This is available on the FGCA website, but a great resource for those across Canada. Yes, it says Eastern Ontario. However, a lot of the basic practices and the data sheets to collect seed are available and transferable across. And as an organization, nonprofit, we are a membership-based organization. Happy to continue this conversation with you about that and certainly follow along with what we're doing at the FGCA to learn more and reach out after this session if you want for any questions you have. Thanks, Amber.
Awesome. Thanks, Kerry. I'm just going to share Trevor's intro slide here. All right. So next we have Trevor Jones, who joined the Canadian Forest Service as a research scientist in 2018. He's the science co-lead of the Adaptive Silviculture for Climate Change project in Petawawa, Ontario, Canada, as well as the Great Lakes St. Lawrence Biomass Harvesting Experiment. His research focuses on the effects of partial harvest silviculture on residual stand structure, species diversity, and site productivity. He also looks at the quantification of forest resources using remote sensing technologies and the restoration and recovery of degraded forests. Thanks for being here, Trevor, and passing it off to you.
Thanks, Amber. I will get my presentation up, hopefully. And
just loading.
Move that out of the way.
Yeah.
We good?
Good to go.
All right. Fantastic. All right. So I'm going to talk to you a little bit about operational assisted migration work that we've been doing in conjunction with our Adaptive Silviculture for Climate Change project. We're in we started the project in 2019, and we're 7 years in now and have some results to share with you. Oops, hold on. So the Adaptive Silviculture for Climate Change is a network of research sites across North America. There's in total 19 sites, 2 of which are in Canada, one at the Petawawa Research Forest and one at the John Prince Forest out in BC. And the idea of the Ask network is to really test the effectiveness of different climate change adaptation strategies and treatments. The idea is to do this in operational context with tools and things that are sort of used traditionally in forest management practices. And so different harvesting systems, planting, tending, that sort of thing. The Ask network runs off of a framework, and all of the sites are the same across the country. They have basically 3 different sort of adaptation treatments: resistance, resilience, and transition, as well as a no action control, and in our case, a business as usual control as well. And so these different adaptation strategies basically look at sort of different levels of intensity in order to figure out how to adapt for us. And so in this example, resistance treatments aim to perpetuate the same forest type by using tactics that may improve defenses or reduce risks. Resilience allows sort of more change into the system, but it'll still be basically the same type of forest, although it may have greater ability to rebound from disturbances or to resist disturbances. And then transition treatment is really sort of looking at the most intensive sort of treatment. And it creates a forest that doesn't necessarily look like the original, but is expected to be more future adapted and is supposed to sort of look and feel sort of and be productive in future climate scenarios. So the Petawawa Research Forest is a 10,000 hectare forest about 2 hours west of Ottawa in sort of the Great Lakes St. Lawrence region of central Ontario. It's predominantly a pine and oak forest right now, pretty sort of dry, sandy conditions. And it's been a sort of research hub and of forestry and knowledge transfer for over 100 years now. It was the first research forest in Canada and still one of the sort of longest serving research forests in Canada. And so what do we expect from climate change? Well, as Dan was talking about, sort of there's a bunch of sort of expected outcomes from climate change. The biggest one is that temperature is expected to increase over the next, 50 to 100 years, depending on sort of what our socioeconomic pathways we choose to travel down. In Pembroke, which is close to Petawawa, we're expecting sort of a fairly substantial increase in average temperature over the next sort of 50 years or so, as well as increase in annual precipitation. The one thing that we are pretty concerned about, though, is that that increase in precipitation is mostly through the spring, fall, and winter. But that in the summer, when sort of the trees need water the most, there's really expected to be sort of significant decreases in precipitation, leading to sort of droughts and water deficit situations. And so this has fairly significant impacts on sort of what can grow and what will be growing in that area. And so this is sort of the thing that we sort of focused on mostly in order to figure out, what seed we wanted to plant, what species composition, and what silvicultural strategies we wanted to employ to help perpetuate forests at Petawawa. And so I'm going to quickly go through the different sort of treatments at the research forest. So the resistance treatment that we chose is a uniform shelterwood treatment. If you don't know what that is, it's basically where it's a partial harvest system where you thin from below and remove up to 50% of the canopy. And it's mainly used to regenerate sort of pine and oak species. Um, we believe that the uniform shelterwood system has some inherent uh, properties that allow it to adapt to climate change, in that it retains a fair amount of overstory cover and allows us to sort of uh, intervene and plant a whole bunch of different species underneath. The resistance portion of this, how we're changing things in here, is that we're doing a bunch of assisted migration sort of plantings, and we're moving seed from 3 different climate zones. And those climate zones were projected from the seedware model and that Dan and others created. And so we used 3 different time windows and three different climate matching for climate seed zones. And so the ones we used were 2011 to 2040, 2041 to 2070, and 2070 to 2100. And so basically looking at where the future climate of Petawawa is, and then selecting seed from those zones. The resilience strategy is intended to perpetuate the original growing conditions, but increase the ability of the system to bounce back from disturbances. With this in mind, we've developed a resilience treatment around the expanded gap irregular shelterwood, and essentially our harvest target about 20% of these stands in small gaps. And then in these gaps, we'll plant a mix of southern pine and oak species, with the idea that these gaps can be expanded over time, and that with each of these expansions, we have an ability to come back, do some adaptive forest management, and change sort of what we're planting, how we're planting it, and that sort of thing. In this treatment, we're modifying the structure quite a bit. We're creating a lot more diversity. We're creating structural diversity in the forest. And so by increasing that diversity sort of within the stands and within and between species, we hope that if there are sort of droughts, insects, whatever else, disturbances, that portions or all of the stands or sections of the forest will survive. The final treatment we're going to talk about today really is this transition treatment, which is meant to be outside of the box thinking on how to create climate adapted forests that are still diverse and produce sort of the similar goods and services that the current forests give. For our transition treatment, we're going to step away from sort of white pine, which is sort of a fairly drastic step. And we're going to be clear cutting it and replanting it with things like pitch pine, which grows in rougher, drier terrain typically, and sort of is definitely a range expansion or a type of assisted migration. Basically, what the idea here is to increase diversity by planting a whole bunch of different things, all of which are from southern seed sources or sources that are already better adapted to warmer and drier conditions. And so the seed sourcing procurement happened in sort of the 2021 to 2020 era. We did some climate matching using seedware models and the RCP 8.5 scenario. As I said, we had 3 zones that we were sort of projecting forward. And so as you can see in the figure on the right, so that first window, sort of the orange represents sort of matching climates for the Petawawa in the future. you're looking into sort of climates that are sort of south and west of us. And as time goes by and you sort of increase those climate windows, you get even further west and south. And so basically that was our indicator of where to find our seed from. And so all of our seed sources from this experiment are from either one of those three sort of climate zones, if we can. We contracted FGCA to do a whole bunch of seed sourcing and acquisition for us. And that was by far the best money that I've ever spent in research. They were great. I don't think that we'd even be close to getting our trees in the ground right now if it was left up to us. They were able to reach into the States and use their contacts and knowledge to acquire all the seed that we needed. And between them and the National Tree Seed Center, who were also awesome, provided all the seed we needed for our experiment. And so it was great to have both of those organizations helping us out, and we couldn't have done it without them. So so as I said, the FGCA acquired all the seed for us. They were sort of sent to a grower out in Kempville who started growing them in 2022. This was not to say that it went without any hitches. There's lots of seed crop failures. There's lack of seed collecting infrastructure. And sometimes nobody even knows where the local sources of the seed are. There's a whole bunch of challenges, and just because there was, a climate envelope doesn't mean there's seed available for us. And so overall, there's a little bit of a cautionary tale here, and that sort of operational adaptation work relies on assisted mitigation, does require finding seed outside of your local zones, and it's not always easy to do that. And it can get fairly complicated when you have to reach into other jurisdictions. So in our case, we had to reach down into the States on several occasions and sort of move seed that is a little bit challenging, like white oak. And so it was not easy, and it was not without some failures. And so be warned, as Kerry said, plan in advance and sort of that'll be beneficial to you. So on to some results. So what I'm going to show you here is some results from the seedlings we planted. These seedlings were planted in fall 2023. They've been in the ground now for just over 2 years, and these results are preliminary data based on the end of growing season in 2025. So sort of hot off the presses here. The next 4 graphs I'm going to show you all have the same sort of look and feel to them, where seedling height is on the top panel and 1 to 2 year post-establishment survival is on the bottom. The species codes are on the right-hand side. So PR is, for example, is red pine. Those are sort of Ontario short forms for things, but we'll keep them up on the screen for you. And then the climate matching locations are either local 1, 2, or 3, and those are sort of matched with those. So what we're looking at here is our business as usual. So this is sort of a normal shelter wood in white pine, and so in this case we planted local white and red pine. And really, what this is showing is that thankfully our industrial standard silviculture is pretty effective at growing trees. We have over 90% survival, and the growth is, they're at 40-ish centimeters now after 2 years. So doing pretty good. So the resistance treatment, this is where we're looking at those 4 different populations or seed sources of pine, starting on the left-hand side, which is the local, and then moving further and further south as we go from PW1 to PW3. And so what you can see here mostly is that sort of the survival and growth of these different seed sources didn't really change that much between the and that sort of the ones from further south seem to be surviving similarly to the ones that are local, and their growth is about the same. They're all sort of cooking away at around 35, 40 centimeters height right now, and survival is again in that sort of 90% range, which is pretty good. A resilience treatment is that expanding gap. This treatment planted a couple of different seed sources of white pine, from southern seed sources, as well as some red oak from sort of 2 southern seed sources, and also white oak. And so the white oak, this was some of our cautionary tale in that we had some sort of fungal issues with the white oak, and then we had some mice that came in and ate a whole bunch of the white oak from our experiment in the greenhouses, and so we weren't able to plant out as much white oak as we wanted, and so we had to sow a population of white oak into this treatment. And so it's slightly different than the transition treatment, which was all planted seedlings, but after 2 years, those white oaks seem to be doing pretty well. They're about the same height, and their survivorship is really good. Again, sort of no huge differences here. All of the species, regardless of where they're from, are doing pretty well. The red oaks seem to be doing equivalently, and the white pine, interestingly, the slightly more southern seed sources seems to be doing a little bit better, but generally speaking, they're all cooking away pretty well. Transition treatment, this is the one where it was a clear cut with a whole bunch of species introduced to it. And so we have 2 species of red pine, pitch pine, which was that sort of long distance sort of assisted migration, a red oak from southern seed source, and then that white oak planted at seedlings again. And so what you can see here is really that, the pitch pine, if it survived, is doing pretty good. It's growing really well. And all the other seed sources seem to be cooking away. And so basically, it's really good to see that all the non-local species are establishing and growing in our treatments. And as time goes on, we'll get a better idea how they survive and compete against each other a little bit. Again, this is only 2 years after planting, so very preliminary results. But, from the science perspective, we're pretty happy to see that things are again surviving and growing, and that our southern seed sources are doing pretty well. So that's optimistic, I guess, but time will tell. We'll probably need to do some competition control in the next couple of years. We have blackberry up to our eyeballs right now, and I think we're going to be needing to do that in the next 1.5 or 2 years and release some of these trees. Other than that, we'll be back in to do long-term monitoring on these plots over the next 15, 20 years. And we'll let you know how things are going.
Great. Okay. Thanks, Trevor. Oh, sorry. I thought you were finished.
I am
Go
finished.
ahead. Okay,
Sorry.
great. Awesome. It's good to hear about what's happening in Petawawa. I know that there's a bigger network, right, in the States and everything, so it's it's great to hear some progress. Okay, so next we have Naomi. Yeah, so we have our 4th speaker with Naomi Butterfield. So starting out as a tree planter, Naomi has specialized as a reclamation ecologist with over 6 years of experience implementing these types of projects across Canada's northwestern forests. She holds degrees in forest conservation science and northern studies, where her research focused on boreal system recovery following thaw slump disturbances in the central Yukon. As part of Yukon Seed and Restoration, she is dedicated to community-informed restoration. So I'll take it away, Naomi.
Thank you. Is this working?
Yep. Yeah, looks good.
Okay, amazing. Okay, hi. My name's Naomi Butterfield, and I'm so grateful to be here today to represent Yukon Seed and Restoration at this really important webinar. I'm going to be presenting on community-led stewardship in the Tekwänt'e Forest and the Tagé Valley, and sort of think about all of the considerations that are involved in restoring northern forests under a changing climate. So, Yukon Seed and Restoration, who are we? We're a small First Nations owned environmental consulting company based out of Whitehorse in the southern Yukon, and we conduct a large amount of our work in and around Mayo in the central Yukon in the traditional territory of the First Nation of Nyäk, which is the nation that is a majority shareholder of our company. I'm going to refer to the First Nation Nyäk as NND and Yukon Seed and Restoration as YSR moving forwards. So we work with Indigenous, industry, government, and nonprofit organizations to help them meet regulatory and social goals, and we focus a lot on community engagement and reciprocal learning. When working with industrial clients, it's particularly important for us to represent the interests of the nation, and our mission overall is to seek funding for and implement projects of community concern. We're also at heart a small group of plant nerds and nature lovers who are incredibly grateful to live, work, and play on the traditional territories of the Nyäk, the Kwanlin, and the Tekwänt'e at home in Whitehorse, and many other of the 11 First Nations territories across the Yukon. So, as users of the land ourselves, we're not unfamiliar with the impacts of ongoing changes to northern forests. The temperature is increasing at about twice the rate of southern Canada, um, which gives us shorter winters and longer and more intense fire seasons. What that looks like a lot of the time is fires that burn hotter, wider, and deeper than they typically have. And in particular, burning deeper into the organic layer in the soils reduces the native seed bank in the soils. And in boreal systems, a lot of conifer species such as lodgepole pine and black spruce, while they are serotinous, and the conifer seeds are often held in aerial seed banks, the high severity fire will actually burn through them, and reduce the viability. And so without a native seed bank, the increasing fire activity actually means that forests are becoming less resilient and unable to restore themselves. Increasing temperatures and increasing fire also accelerates permafrost thaw. Thawing permafrost releases carbon and destabilizes the soil, which affects infrastructure and affects hydrology and habitat. So these are all changes that identify sort of the urgency for more effective and ecologically informed reclamation across the north. So, with all of these changes and increasing wildfire, and as a company that is committed to working with community, how do we integrate this into our own work? In many cases, we approach the community ourselves. So, in 2023, YSR got funding through the Indigenous Forestry Initiative to conduct an ecological landscape classification program across the Tekwänt'e forest. The Tekwänt'e forest is in NND traditional territory, and it's an area that has seen substantial fire activity. So here's an NDVI map showing the difference between 2019 and 2023. So we can see there's a lot less growth occurring. And then on the right here, we have photos taken this spring. And it's really important to note here that in 6 years since the fire, we see still very little regeneration, especially of conifer species, partially because of the high severity fire and the reduction of the native seed bank. And so as part of this ecological landscape classification program, YSR held an elders climate change workshop. In particular, questions that were brought to the community were questions on impact and changes seen over time, impacts on plant and wildlife, and visions and dreams for restoration. The key themes that came out of this session included the loss of subalpine fir, which is a fire-intolerant species, habitat concerns, especially for caribou, given that the fire scar encroached into the critical winter habitat for the Ethel Lake caribou herd, and sort of stand replacement, aspen ingress, which is making it more difficult to access traditional medicines. And this once again sort of confirms this idea that conifer regeneration really struggles with increases in fire activity. And so with the use of this local knowledge and how it guides us, this led directly to YSR's application to the 2 Billion Trees program, with a goal of conducting an eco-cultural reforestation of the Tekwänt'e forest. The vision here was to restore the land in a way that supports ecological health, focusing on native species, for instance, the subalpine fir, that is not naturally regenerating, cultural practices because of the importance of, in particular, the subalpine area, which in this photo we are on top of, and the forest as a whole, given that it's an important area for community, and NND's culture camp actually lies on the bank of Ethel Lake, which we see in the distance here. And then also importantly, focusing on habitat value and wildlife use. So this program, like all restoration programs, is rooted in a need for seed. As we've kind of discussed already, native seed is critical for effective reclamation. It is genetically adapted to local conditions, showing us higher germination and survival rates. This is especially important in the Yukon, given that we have very short growing seasons. The Yukon, however, does not have an established seed bank, and we've also heard how sourcing seed materials is often easier said than done. While YSR already integrates seed collection into a lot of our programming, in the case of this project where we needed subalpine fir, which doesn't reliably go to seed every year and requires at least 2 years in a nursery to grow, we started sort of searching around our sources for available seed material. We eventually were able to find the very last subalpine fir in the Yukon government seed bank, which is actually older than most of our employees. It dates back to the 1980s and tested at only 14% viability. This really highlights the need for the establishment of seed banks and native seed materials, so that the Yukon and other areas that don't have the capacity can really enhance their restoration capacity. So while we were already doing it, this really highlights the need and priority of YSR to include seed collection as part of all of our programming, and in particular, doing our collections and all of our processing in-house, processing that involves drying out the seed, removing the chaff from the seed materials, and then banking the material under climate, temperature, and humidity controlled conditions. We're able to identify the provenances that we collect, and this is letting us start to begin to use a climate adapted seed transfer method within our own planting programs, using a variety of genetic diversity, moving sort of more southern provenances up into the central to prepare and start to work towards the changes that we already see across our landscape and anticipate future conditions. Because as some people have mentioned, other, especially the provinces, they have territory, they have seed zones and established information for transfer ranges. The Yukon doesn't have this, and so we have been using eco zones rather than seed zones, just because we sort of lack that side of of the regulation, and the ratios for the transfer are determined on a species by species basis based on their tolerance to manage temperature shifts. So this was an example where we went to the community to try and identify the priorities and needs that they had. This next example is an example of the community coming to us. So in 2024, last summer, the NND Lands Department approached us regarding urgent concerns they had in the Tagé Valley. That concern was that in an area that has experienced a lot of wildfire, this had accelerated permafrost thaw, which caused thaw slump activity. For those unfamiliar with permafrost disturbances, if permafrost is ice rich, once it thaws and the ice melts and runs off, the ground essentially loses structural integrity and will collapse in a landslide-like manner. The continued exposure of the head wall, which is still permafrost that has not yet thawed, will experience thermal erosion from the outside atmosphere and continue to erode, creating this kind of positive feedback loop where the erosion continues. In this case, as we can see in this bottom image here, there's landslides sort of all across the slope, and there's risk of the material, which is essentially the removal of all organic top material and the fines in the mineral soil running down the hill slope, and risk entering Haggard Creek, which unfortunately was cut off this drone imagery, but it follows the road quite closely at the bottom here. This is a creek that supports salmon, grayling, and char. It's important for the community and was already determined as being subject to cumulative effects even before this thaw slump activity began, and the 2024 heap leach failure just upstream from the area released enormous amounts of cyanide into the watershed. So this is a really important area for the community. And so we decided with this ask to pivot a portion of our 2 billion trees funding into moving and working where the impacts are highest. But because of the nature of the thaw slump activity and the head wall, this presented a new restoration challenge. We were able to use sort of your normal erosion control and bioengineering methods. Bio, the use of plants, engineering, sort of enhancing structural stability for the erosion in a bench structure up the slope, as we can see on the bottom left here. But for the head wall, we had to come up with some new methods and piloted sort of using fence-like containers, fence-like structures to contain the head wall and reduce thermal erosion by introducing the live materials and covering them with a moss mat layer to provide, again, both the structural and biological support, and with this attempt to cover it up and increase live material growth in it to reduce the thermal erosion. Our takeaway from this is that as climate change creates new unfamiliar conditions, we have to adapt our restoration methods to meet the new conditions that we're facing. Here's some more images from the top of our slope after it was completed. We have a mixture on this map on the right. You can see the sediment logs, fascines, woody debris, fascines, like a mix of live materials and non-live materials to really try and catch the erosion as it comes down the hill slope. So working towards climate resilience, we really believe the people that can identify the critical issues in a changing landscape are those who live on it and use it. We think it's really important when thinking towards a more resilient forest to use community-informed priorities to focus on seed sovereignty and enhance the capacity of an area or the territory to invest in reclamation through establishing a seed bank, and also be open to be willing to develop and trial new methods to address the new and changing conditions. Our work is guided by the communities we serve and the changing landscapes that we share. So climate resilience is a shared responsibility and a shared opportunity. Thank you. Merci, Joe.
Awesome. That was great, Naomi. Thank you. So next we have last but not least, we have Greg. I'm just going to share screen, give a quick intro. We're really happy to have Greg with us today. Final speaker is Greg O'Neill. Greg is a professional forester and former arborist with degrees in biology, forest ecology, and genetics. Having worked for 25 years in the forest genetics section of the BC Ministry, Greg studies the adaptive variation of Western North American tree species and applies this understanding to develop resilient reforestation practices in a changing climate. Much of his time is devoted to two large field trials. One is the Assisted Migration Adaptation Trial, and the second is the Interior Spruce Genecology Trial, as well as working on the development and implementation of BC's climate-based seed transfer system, or CBST for short. We really appreciate you being here today, Greg, and lead us through the next presentation. Thanks.
Thank you, Amber. Can you hear me okay? And is
Yeah.
my slide good? Okay, great.
Yeah, all seems to be working.
Thank you, Amber, and thanks to the previous speakers for setting this up so nicely. And I'm speaking today from the unceded territory of the Stillix people. All right, so on the right here is a giant sequoia from Central California, and it's about 3 years old, and it's a meter tall, and it's growing at 1,400 meters near Nelson in southeast BC. The reason it's growing so well is that the climate in southeast BC at 1,400 meters is almost identical to that of giant sequoia's native habitat at the mountaintops in Central California. So this is just a reminder throughout this talk to try to think climatically as opposed to geographically. Okay, so moving on. Okay, so I'm going to talk about rationale for climate-based seed transfer. I'll talk about the system that we implemented here in British Columbia, and I'll address a few concerns about assisted migration and climate-based seed transfer. I'm not going to show any slides of forest catastrophes. You've seen them many times, but instead I'm going to show this slide here. This is work done by Derek Sattler of the Canadian Forest Service. And in the black, we see on the black line here, this is a growth curve. This is age, so volume over age curve. This is what we would expect on a typical southern British Columbia location, volume over age. And Derek took some provenance data. This is data where we have trees from many locations, growing in many locations. And he was able to use this to tweak both the height curve and the mortality curve for lodgepole pine. And then he used that in a very smart way to model the interaction between height and growth in stands of lodgepole pine. And he determined that at rotation, one would have, if you have a stand planted in 2010, at rotation, 90 years after establishment, you should expect about 22% less productivity in southern BC and 17, 18 in central northern BC. So these are pretty major impacts, and keep in mind, these are also impacts to the goods and to the ecological services associated with that lodgepole pine stands provide. So we see, the question is, why is the red line lower than the black line? It's because climate change creates this evolutionary lag, and think it was Dan who indicated that the climate is migrating much faster across the landscape than populations are themselves. So it creates this evolutionary lag, which results in maladaptation, which results in reduced growth. But with assisted migration, we can reduce the evolutionary lag, therefore reducing maladaptation and trying to maintain some of that growth that we might expect to be forfeited due to climate change. And I'm going to brazenly steal from Tan's publication in 2014. So you don't need a lot of statistics here to see that the plant hardiness zones have shifted dramatically in Canada in the last 50 years. And in forestry, because forestry is a very long-term proposition and you cannot protect the trees in the same way that you can in horticulture or agriculture, we need to be even much more concerned about what materials go into the ground at establishment. This is British Columbia's former geographic-based seed transfer system. In this system, if you have seed from the bright green zone, it stays in the bright green zone. And that's great. It's very simple to implement, but it does have its challenges. It has limited deployability for foresters who might want to have a seed collection. If they can only plant it in this little green area here, that's a problem. And then this system does not lend itself to assisted migration very well. So fortunately, we happen to have this very well-developed ecological classification system in British Columbia with 207 called the BEC, biogeoclimatic ecosystem classification variants. We'll just call them variants. 207 variants. And these are areas with similar plants, animals, and climate. And we can exploit this and to develop our new system. So I prefer to look at things climatically as opposed to geographically. So we're going to take those 207. We'll take the climatic mean of each of those variants, and we plot it here across two climate axes, temperature and precipitation. Now, pretending you are a forester with a cut block at that green diamond, you would, according to the paradigm established in forestry 100 years ago, you would plant local. You would collect your seed from locations that are climatically similar to the planting location. Along comes climate change, however, and we need to procure our seed from locations that are slightly warmer than that cut block's current climate. So we migrate the focus of procurement to a location that's slightly warmer. That becomes our new procurement location. So we can now collect seed from any location inside this red oval. And I should point out that in the actual system, we do this with 7 climate variables, not just 2. But for illustrated here with 2 variables. So what it looks like on the ground is your plantation is here, and you can procure your seed from any of these ecosystems, any of these BEC variants. So these are climatically similar BEC variants, climatically similar to the variant shown in red. If we were to implement assisted migration in this system, we shift the procurement focus to variants that are slightly warmer, and that's what we see here. We haven't yet developed this into the States, but that's our next project. Okay, so the question then is, well, there's 2 things we need to calculate to do this. Number one is this vector here, this migration distance, and the size of this oval. So now I'm going to show you how we calculate these 2 things. So just taking Enderby as a village just north of Vernon, half an hour. And we see here the temperature, mean annual temperature of Enderby from 1990 projected up to 2100. We fit a curve to that data. So here, the temperature, the mean annual temperature in Enderby right now, or this year, is probably around 6 degrees. Its historic, or its ancestral climate, if you will, is about 1.5 degrees less. So if you're a forester planting seed in Enderby, where would you get your seed? Well, if you get Enderby seed, it's already 1.5 degrees behind. Like it's 1.5 degrees adapted to a climate that's 1.5 degrees colder than Enderby's current climate. So let's say you go to Osoyoos, where the temperature is 1.5 degrees warmer than Enderby's current climate. It's 7.5 degrees. Well, great. You've got perfectly adapted seed at establishment. However, that tree needs to be in the ground for 60 or 70 or 80 years. So we need to migrate it just a little bit further, knowing that trees are most sensitive in their first couple decades of life. We chose 1/4 of a rotation, about 15 years into the future. So we add an additional amount onto that. This becomes what we call the migration distance. We calculate this distance for 7 climate variables, and that's the vector that I just showed you on that previous figure. The second thing we need to calculate is the size of that oval. What's the procurement space? Here we take this. We're very fortunate in BC to have this wonderful lodgepole pine provenance trial. Here are 60 populations planted at Community Lake in central British Columbia, where the mean annual temperature is just shy of 3 degrees. And we see that we can fit a nice curve here. Here's 2.9. And if we want our seed, if we're planting at a site with a climate similar to Community Lake, then we should get our seed from between these 2 red vertical lines. We call this the safe seed transfer distance. So we calculate this distance, and that informs our the size of that oval. So this was implemented, this was written up in this Tech Report 99. It was implemented in our online seed request system called SPAR. And it was reviewed, went through a thrashing of reviews. It was implemented as optionally in 2018 and mandatory in 2022. It applies to all species, all parts of BC, orchard and wild stand seedlots. We are monitoring it. So far, we've had really good uptake, in large part because the actual calculations took us 2 years, but the implementation, these reviews and engagement took us 5 years. So it was a slow process, but it was worth the effort. Okay, just to verify the system, a couple of years ago, Dawe Luo and I developed a little analysis. We created 40,000 random transfers. We took 40,000 random seed source locations in BC and 40,000 plantation locations in BC, and we matched them up. And then we asked the question, of those 40,000, which of these would be legal in the former geographic-based seed transfer system, which would be, quote, legal or acceptable in the climate-based seed transfer, and which would be acceptable in the climate-based seed transfer system with assisted migration. So we know the seed source location, the climate at that location. We know the climate at the at the plantation. So we know the distance, the climate distance the seed has been transferred. We can therefore calculate the impact on productivity using a transfer function. And we know how many red arrows there are, so we know how deployable the seed is. So with lodgepole pine, it turns out that if we're looking at height here for those 3 systems of seed transfer, the height is not significantly different between CBST and GBST, between climate-based seed transfer and geographic-based seed transfer. It's assisted migration that contributes to the height increase. However, when we look at deployment, how many hectares can we use on average for a given seed lot across British Columbia? How many hectares can we deploy that seed to? There's a massive increase in deployment with CBST and a large increase with CBST with assisted migration. So you may ask, well, why would assisted migration reduce the deployability of seed? Well, that's because seed in northern BC has nowhere to go. I mean, we didn't include Yukon and the north into these calculations. So, but what we do see is that it's CBST, this shift from a focal zone, from a fixed zone system to a focal zone system that increases the deployment area for seed. And we have similar results for interior spruce, increases due to assisted migration, increases in height, and increases in deployability due to shift to a climate-based seed transfer system. When we convert from height to volume, what we see is a 15% increase in volume growth rate at rotation for lodgepole pine, and a 6% increase for interior spruce. When we compare, so that's an increase over the old geographic-based seed transfer system. And an increase in deployment, we double the deployment area, and we double it for pine, and we increase it by 7 times for interior spruce. So massive increase in deployment area. So this makes life a lot easier. It's kind of a win-win. The province is happy because we have greater volume, at least not greater volume, but we have less forfeiture of volume due to climate change. And foresters are happy because every seed lot they collect, or orchardists are happy because every seed lot they collect can now be deployed to a lot more hectares. So what are some of the concerns with assisted migration? Well, sometimes I hear, well, will those trees grow in their new climate? Well, let's just think about this. In the no assisted migration scenario, we know the climate has already increased by 1.5 degrees. So the site is 1.5 degrees warmer than the seed at establishment. At harvest, the site is going to be 3 degrees warmer on average, maybe more in the north. So the trees are going to be experiencing 4.5 degrees warmer climates than their historic climate. So they start off at 1.5 degrees warmer, and at rotation, they're 4.5 degrees warmer. They're in a climate that's 4.5 degrees warmer than their ancestral climate. Compare that with the assisted migration situation, where at establishment, we're planting trees that on average are from a location that's 0.5 degree colder, because we've gone into the future here a little bit, 0.5 degree colder at establishment. At rotation, at harvest, when the site is now 3 degrees warmer, these trees are now experiencing a climate that's 2.5 degrees warmer than where they evolved. So tell me, which of these two scenarios is more risky? Well, I think it's pretty clear that the risk is greater with this assisted migration, with the no assisted migration, particularly because way out here they're going to have a hard time establishing, harder time establishing, and because the curve is exponential, we're going to see a lot more risk at rotation here. All right. Another refrain I hear is we can't do assisted migration because we don't have provenance trials. Well, you already do seed transfer. If you're planting trees, you're getting those seed from somewhere. You've got some rules or some legislation or some rule of thumb about how to do that. Well, you don't have to reinvent the wheel. Continue to use those climatic distances that you've always used. And in fact, here's some unpublished work from Joseph Stewart from California, where he looked at 5 different species and compared the safe seed transfer distances for those 5 species. Turns out they're very, very similar. Similarly, Sally Aiken and Jordan Bemmels back a few years ago, they write that the species show climatic gradients sufficiently similar to guide assisted migration in the absence of species-specific knowledge. That is, you don't have to have transfer curves or safe seed transfer distances to do this work, obviously, because in most parts of the world, in most parts of Canada, and for most of British Columbia, we don't have transfer curves for most of our species. We rely upon spruce and pine essentially to help guide us. So if you're not sure, you choose a conservative, you choose the steepest curve, and that's fairly straightforward. Now, another refrain I hear is, well, will they survive outside of their range? Well, here's just a schematic of British Columbia in here, and we have just a nominal species and its geographic distribution. It's today and its future geographic distribution. And Dan mentioned a couple types of assisted migration. We have assisted gene flow, or sometimes called assisted population migration. From any point inside the thick black line to any other point inside the thick black oval is assisted gene flow. When you take seed from inside its current distribution and move it outside into its future range, that we would refer to as assisted colonization or assisted range expansion. Well, the area here is a tiny fraction of the total area of the black oval, number one. So that implies that most assisted migration taking place in Canada will be of the assisted population migration variety. So that's the variety where most people aren't even aware. I mean, it's still important to do it properly, but the point is that we're not moving species outside of the range very often. I think there's this perception that assisted migration means, whoa, planting species like, God knows where. No, most of it is this assisted range expansion, and a tiny proportion will be moving it just outside of its current natural range. And in fact, we were fortunate to have some data with which to test these movements. Hardy Griesbauer and myself and Will Mackenzie found 26 locations where three species had been moved outside of their range in central British Columbia, and they actually grew faster and survival was greater outside of their range than inside their range. And if you ask, well, how can that be? Well, go back to that illustration of Enderby, where we see the climate has already increased 1.5 degrees. So their climatic home, if you will, has already migrated north or into colder climates. Someone earlier today mentioned the need the first question with assisted migration is to select your species. And sometimes this gets forgotten. And I often hear this question, well, will they survive in different soils? Well, the answer is no, they won't survive in different soils. You can't take Douglas fir adapted to relatively dry soils and stick it in a soil where the water table is 30 centimeters. You can't do that. And so BC has this very well-developed species selection tool to make sure that you get the species selection decision right. So my point is, no, they won't survive in different soils, but assisted migration does not imply that you're going to move them. Please don't put them in different soils. Put them back in the same soil that they originated from. Okay, enough of that. I sometimes hear that the climate uncertainty is too great. well, we can't do assisted migration because we just don't know what this climate's going to be like in 100 years. Well, we don't need to know what the climate's going to be like in 100 years. What we need to know is what was the climate back here in, say, in its ancestral climate back a few decades, and what will the climate be like just a little bit into the future. And we have data for this. So this we can just calculate. This we need to model, and there's lots of models for this, but the models do not diverge very greatly by 2040, 15, 20 years into the future. So there's very little uncertainty about either of these. Okay, to conclude, climate change is not good for trees. We restore populations to their restoring populations to their historic climate can help reduce the impact of climate change, and the risk of action is small relative to the risk of inaction. Okay, thank you very much, and I will stop there.
Awesome. Thanks, Greg. We're a bit over time, but that's not a bad thing. I think it's been a lot of really good presentations today. I just want to make sure we can share where this is all going to be hosted. The recording basically will come out in a few days' time. You can all find it on the Knowledge Hub here. English and French versions of today's recording will be there. You'll also find our 3-part post-wildfire restoration series that we did last winter if you are interested in checking that out. I also want to plug Forest Canada's QR code here to sign up for a newsletter, news events, resources, and more. QR code there, and you can sign up for other events that come up. So we will now open up Q&A. So I'm asking all the speakers to please turn on your video camera if you'd like to. I think what I'll do is I'll start with the top voted questions first, since these are the most popular ones. I think this goes back to Dan. So this question for Dan, you talked about different types of assisted migration. Can you elaborate on when these types might be most appropriate and how they might differ between gene migration, range, etc.? I feel like Greg might have answered a few of these, but
I was
Dan.
just going to say that,
Yeah.
Greg's in a province that is actually, officially doing some of this stuff already. And the fact is that the last point that Greg was making, the population movements is pretty risk-free, and it generally means moving populations north or upward in elevation in Greg's world, and they are going to be better genetically adapted. It's often the same species, given all the points about soils and making sure that you're not trying to grow a species, in a bog that's not meant to be in a bog, that kind of thing. So that kind of assisted gene flow is good, and basically the climate's already not local, especially out west.
Mm-hmm.
The climate is changing much more rapidly out west. So
Right.
it's smart and pretty risk-free. And for the most part, we're not talking about moving new species northward. We're not going to be moving catalpa tree up to the boreal forest. I don't think that's not public policy. Gardeners might do it in the context of plant hardiness. People are always experimenting. You don't want things to become invasive, but in the world of operational forestry, we're talking about a limited number of species.
Mm-hmm. I think that might lead to the next question from Mike. Greg, in BC, is there guidance for the amount of seed to source from alternate areas, so percent local versus percent transferred? Or is it expected that when you use seed transfer, that all the seedlings are from alternate sources?
The latter. It's expected that when you have a cut block, you go online, you enter the ecosystem, you enter the species, and it gives you a list of seedlots to select from. Those seedlots are entirely from that future, the future climate. Yeah. Now, we get on average about 50% natural regen coming back into the forest. So it's not like there's only going to be those planted trees. There's still a lot of advanced regen and natural regen there.
Yeah, that makes sense. This one's for Trevor from Dean. With the assisted migration of other pine species, is there opportunities to hybridize with introduced species? I don't know if you're comfortable taking that one, Trevor. It's maybe controversial.
I am very not comfortable taking that question. I don't know too much about hybridization between species at all. So
Maybe Carrie, yeah, Carrie's got her
Kerry,
hand up.
there you go. Thank you.
Yeah. Dean, hybridization is one of those things that, but many of again, based on where we are in Southern Ontario, we are looking to the US, and that's been a lot of the word of caution from the US Forest Service folks that we've been connected with is you really have to be careful with hybridization. Um, we did face that with one of our assisted migration trials where we thought we were bringing up red oak and it was actually blackjack oak and it ended up being a range expansion assisted migration trial on that particular species. But yeah, you really have to be careful with hybridization. On the pines, not so much as the like some of the hardwood species that people might move.
Mhm. Another one for Trevor. If one of the graphs showed not a lot of difference in survival rates between the assisted migrated species and then the one that's growing in its natural environment. So what's the argument to make for encouraging assisted migration if its survival rates are the same? Like I think there's one question about that box plot that you showed.
Yeah, I think the question here is that basically you're moving things that are sort of future adapted, similar to what Greg was saying, is that, as you move them up from sort of a place that's sort of, that sort of warmer, drier already into a cooler place, then there may be some mortality events. But as climate changes, they're going to become more adapted or better
Hmm.
adapted to their future climate. And so they're
Hmm.
right now they're surviving the same as local populations and growing the same as local populations. And the hope is that as things get tougher for them in the future, that they will, grow and survive better and become a seed source for the future.
Hmm.
I think one of the important things here is that from a forestry context, is that we're really trying to sort of bolster the number of population sources and sort of those southern seed sources into current populations to give them more sort of diversity and opportunity. And so if there are some things about the local population that are not sort of adaptable to those future climates, that there'll be sort of a backup, sort of analog already in the system that helps us sort of be more resilient to
Hmm.
sort of those disturbances and that sort of climate change, gradual climate change. So
Yeah. Yeah, so it's about the future versus the
yeah,
present. That's a good answer.
yeah.
This one's for Naomi. In your opinion, like just from your experience, are First Nations in Yukon and elsewhere in Canada on board with assisted gene migration, species colonization, like movement of species? How are the communities feeling?
I can't speak for like a general understanding of that. I can only
Hmm.
speak for the conversations that we've had with our nation. And there's obviously some hesitancy around these kind of conversations, especially given that one of our takeaways from our climate change workshop was that there is an ingress of deciduous species that sort of don't allow conifer regeneration. Um, and we do see, for instance, in Whitehorse, we are creating a fire break and growing aspen in order to sort of remove conifers around the city. Um, so there's definitely some wariness, but in especially in the Tagé Valley where we're working, like the priority is on doing what we can with the science and traditional knowledge that we have to promote growth as fast as we can and really stabilize those slopes because in that instance, like the critical um, interest is the creek.
Hmm. No, that makes sense that you can't, yeah, obviously for speak for all of them as well. This one's for Greg. What effect does lower winter and longer summer light have on tree seedling establishment and growth? I feel like this maybe have to do with latitude. This might be latitude related.
Right, yeah. Um, from our 1,000 provenance trials, we have found very little effect of latitude per se. When you put um, temperature into the
Mm.
equation, then there's a large effect. Latitude does not seem to have a very strong effect itself, just by itself. Yeah.
Mhm. This might be a good one for Dan. So you mentioned that things are becoming warmer and wetter. I think a lot of people maybe heard the opposite, that things are being more dry, possibly as a result of higher temperatures. Can you elaborate on the wetter observation? You're on mute, sorry. I'll take you off if you
Sorry.
or there you go.
Um,
Yeah.
yes, I can see why that might be a little confusing. I think the thing to keep in mind is that there is spatial variation in temperature changes and even precipitation changes. The warming that much of what we're seeing is definitely getting warmer for, in the west and moving eastward. That is predicted in all of the global change models. And the other thing, I wrote down some notes about this when I saw the question, is that in a lot of times too, we're thinking about there's there's temporal variation to events, right? So are we talking about weather? Or are we talking about climate? You know, we've seen changes in weather lately that's caused a lot of fires. For trees, of course, respond to weather at times, extreme events, but they also respond to climate, sort of the long-term conditions. And I think this is what sort of tools that we're talking about, and Greg is implementing, and in Ontario as well. Um, this is part of what makes it challenging to know what the best way to think about these things. But the trend is supposed to be probably more extremes, dryness at times, wet at times, and we have to try to figure out the best way to respond to that. And I think hopefully that answers the question in a without backing myself into a corner too much.
No, that's good. Maybe Kerry could answer this one. The cognitive bias and emotional decision making. What's your kind of thoughts or the takeaway on actions to counteract it versus genetic diversity? Basically, working with the site versus working with the people that manage the site.
Yeah, I mean, I think it just there's this overwhelming sort of drive for people to do this, and I think it's also very paralyzing when you think about all the elements you have to do, and I think breaking it down into small and tangible um, elements. And what we've been trying to do is work with people regional. If you take this in mass scale, it becomes impossible. Regional people that know their areas well, know their landowners, know their communities, their forests. That's the level we have to be working at to make these kinds of decisions with seed movement. And I think we reduce that. There's obviously going to be a little bit of bias regionally, but I think there's also this, Greg mentioned the risk tolerance. And risk tolerance is going to be very different for a private individual landowner that's receiving afforestation work to a crown forest operation that's producing, seed, supply for wood timber supply. So this, I guess it really has to people have to look at evaluating risk. And Greg made a really excellent point that the do nothing scenario is now far riskier than a doing something scenario. And so I think that's where we have to shift, because everyone before was like, "Ooh, if I move one seed zone, is that okay?" I'm like, "Heck yes, let's go." That's kind of nothing in the grand scheme of things anymore. So I don't know if I'm fully answering that, but I think it really has to be regional, just like Naomi's tackling this in her area. That's the way we have to do this, and it's baby steps. And if someone's willing to incorporate a little bit, that's great. If it's incorporating a lot, that's great too. It depends on who's doing the work and who's sort of receiving the benefits. So.
Could I just jump in on that one a little bit, Amber?
Sure. Yep. Go ahead.
I was just going to say, like, one of these things, the cognitive bias. So I was thinking about this. A simple example might be this whole idea of framing, and that is, as Kerry's suggesting, and Craig, framing is how you describe something. So we have to describe it well, and I think the point is that you have to spend enough time talking to your stakeholders to understand how they think and how one can best explain these things. So I think if we think about explaining the science well, and that includes things that we still don't know. There's lots of stuff to still learn. But framing is an important point about telling the story of assisted migration in a neutral way to stakeholders in particular. I think they're the ones that have to buy into it.
Mhm. Is there anyone else in the panel that wants to comment on the possible gaps between research and operationalizing assisted migration? So there's a question from Nicholas about, is there things that need to be addressed at the research level, or is it mostly on policymakers, operations to actually communicate the benefits of this? Maybe Greg, or how's BC in general for
Uh,
operationalizing all this stuff?
well, like I said, we did implement this optionally in 2018, and it became mandatory in 2022. Um, I think the trials that Trevor talked about, we need lots more demonstration trials like that. Um, lots of lots more provenance trials to get people comfortable with this notion. Lots of demonstration trials. But I also want to point out that I know this is about assisted migration, but there's and perhaps assisted migration is the low-hanging fruit. There's lots of other silviculture strategies that we could and should be adopting. Um, so it's not the silver bullet. We're going to need lots of microsite planting and shelter wood cutting as opposed to clear cut harvesting.
Mhm.
Lots of other strategies, much more diversity on the landscape in every respect.
Mhm. Yeah, that's a good
Yes.
response. Anyone
Yeah.
else for their region or, oh, sorry, go ahead, Kerry.
Yeah, no, I was going to say there are major gaps from the research and the practitioner community. And I think some of this, like this tool today, is very helpful in sort of translating that information a bit. Oftentimes, again, you don't know where to start, but that's why I'm saying we need to learn from like this is experiential learning. Many careers, you're not going to learn this in one career. It's going to be impossible. I think we need to learn from those that have done it. Um, and I think there does need to be some involvement with sort of government and as well as other individuals working in this space. BC is very well supported in the seed procurement process, whereas other parts of Canada, Ontario, is not. So that will really weigh in on our capacity to respond to this and want to act on it. So that's why the planning windows need to be considered as part of any project.
Yeah, good point. I have a question here about grasslands. Like there's some places that are shifting away from forested lands to more grasslands, non-forested ecosystems. Is that on anyone's radar in terms of species shifts and maybe maybe thinking more about the tree line um, that might relate more to that?
We have some grasslands in British Columbia that are expanding rapidly.
Mhm.
I don't think that it's like trying to bail the rising tide. Unless you can
Mhm.
find a species that will grow there, um, I don't see a forested option for that.
And then there's one more I think you already answered about the southern point of something's like a species range, how to handle those if the southern portion is starting to become maladapted to that region.
Yeah, same. There aren't a lot of those in Western British Columbia, where the southern range of the species is where you want to reforest. But if you do have that situation, maybe it exists more in Eastern Canada. Um, Again, I think the solution is just to select a different species. Try to find a species that will work in that climate.
Mm-hmm. I think that's all we have time for, unless anyone has any burning comments from the panel. Anyone else want to say any last words? I really appreciate you all being here. Obviously, it's a continuing topic. We'll be probably talking about this for a long time to come. I feel like with all the changes happening with climate change. So I appreciate all of your time and thanks to everyone in the audience. And we will follow up with the recording soon.
Thank
All
you.
right. Thanks,
Thank
everyone.
you. Cheers.